Hey guys, good morning. All right, we are doing page 13 today. I'm going to do page 13 for your notes, the entire page. Your homework for today will be the following page, page 14 and page 15, which is this one right here. All right, and I will walk you guys through how to do all of those here in a second, but let's go through our notes for today. So if we look at this, for the most part, this is just a review of how to do it. So I don't know why they gave you notes like in the middle of it, but okay, whatever. So the number of solutions for a system of equation. We already know there are 3 different types of solutions that we can get. The first one, the lines below are called intersecting lines. The reason why they're intersecting means that they're going to be meeting. This is an example. These lines have how many solutions? 1 solution. All right. So what's the characteristic for this one? So the slopes of these lines are different. The y-intercept of these lines are different. All right, so that means that your slope, the number next to the x, should be a different number, and your y-intercept, the number in the back, should be different. So if you see that an equation that you are given has a different slope and a different y-intercept on both, then you know you're going to have intersecting lines, which means you're going to have 1 solution. All right, the other type of solution you guys can have is something like this, where one line is on top of the other. The proper word for that is called coinciding lines. It means it's one on top of the other. They're right on top of each other. So these lines have how many solutions? I'm going to put this symbol, it's like a sideways 8. That's called infinitely many solutions. All right, so I'll write it as well. Infinitely many solutions. I think I spelled that wrong. I don't know. All right, so what kind of characteristics are we going to have? Well, since they're right on top of each other, that means that my slope and my y-intercept are both going to be the same. So both of these lines are going to be the same. So the slope is the same, the y-intercept is the same. Once you see that those two are the same, then you can automatically jump into, oh, they have infinitely many solutions, or just draw it one on top of the other. You don't have to do that much work, which is the reason why I'm telling you guys to focus on vocabulary. If you guys are able to focus on vocabulary, it makes life a little easier because you don't have to do as much work. The last type of solution that you're going to have looks like this. If a solution is when they both touch, well, what can you tell me about these 2 lines? These 2 lines are parallel lines. So do they ever touch? No. So how many solutions are we going to have? Well, none. So we're going to have no solution. How can we tell right away? Well, they'll have the same slope, but you'll have a different y-intercept. All right, so that'll let you know right away that you're dealing with parallel lines if you have the same slope but different y-intercepts. All right, those are your 3 types of solutions you can get. Intersecting lines, meaning I have 1 solution. Coinciding lines, meaning one line is on top of the other, so infinitely many solutions. Or we have parallel lines, meaning that there's never going to touch, so we have no solutions. So that's the notes for today. If we turn the page to look at page 14, let me explain how your homework's going to look like. Questions 1, 2, and 3, all I'm asking you guys is for an example. So draw an example of each type. On the top, sorry, it got all blurry. On the top, I wanted an example of a 1 solution. Number 2, I want one for infinitely many solutions. And 3, I want one for no solutions. So do you have to give me a specific one and tell me the equation, all that stuff? No, just give me an example of how it would look like on a line. You don't have to give me an equation or anything, just give me a simple graph. All right. Question 4 says, is it possible for two lines to intersect in exactly 2 places? Answering complete sentences. So can a line hit on the equation in 2 spots? Think about that and then write what you guys think. Question 5. What type of lines produce the most solutions? Tell me what kind of lines. And I'm looking for intersecting, coinciding, or parallel. Okay? For question 6, what form must a system be written in when comparing both lines? Why? Answering complete sentences. So look at all of your equations. Let me give you an example or a hint. Think of what kind of form they need to be in order for you to graph your lines. So that's a hint. It's the same order as when you have to graph a line. All right? So that's going to be part of your homeworks, and then page 15 will be part of your homework. So I'm going to do the first question for 15, just so that you guys see what you need to do. So for page 15, look at question 1. If I look at this example, here are my 2 equations. These are standard form. Hint, it's not standard form. So if we look at this, how many solutions am I going to have? Is it a no solution, a 1 solution, or many solutions? All right, so looking at this, how many times does it intersect? It intersects 1 time. So I'm going to put a check mark under 1 time. How do I know it's going to be a 1 solution? And the justification can be very simple. Because they cross at 1 point. All right, and that's it. So all you have to tell me is, okay, look at, this doesn't have a question 2. Interesting. The numbering got it all messed up. All right, so look at this. Is it a no solution, 1 solution, or infinitely many? And then tell me, how do you know? Same thing for 4. No solution, 1 solution, infinitely many, justify. These 2, you'll have to probably solve. You can do either elimination or substitution, or if you pay attention to the characteristics, you can be able to tell by that, and you would just justify it through whatever characteristics you guys see. Other than that, that is your homework and your notes for today, and I will talk to you guys tomorrow. Have a good day, guys. Bye.